Headlines often frame the technological rivalry between the United States and China as a race for absolute sovereign independence. This concept is known as autarky, a state of total national self-sufficiency. However, the complexity of modern technology makes achieving autarky impossible. The Belfer Center's 2025 Critical and Emerging Technologies Index tracks thousands of data points to assess national power. It shows that no single nation possesses an end-to-end technology stack. The data maps a global landscape distributed across three distinct blocks: North America, East Asia, and an aggregated Europe. Geopolitical power in this era is defined by the asymmetric control of specific vulnerabilities within a shared system. This chart ranks aggregate scores across 5 sectors: artificial intelligence, biotechnology, semiconductors, space, and quantum. While the United States maintains an overall lead, that power is distributed unevenly. China and Europe match or exceed U.S. capabilities in specific domains, like pharmaceutical production and quantum communications. These sectors do not operate in isolation. Through technological convergence, a breakthrough in one field provides the tools to accelerate development in the others. This diagram of a smartphone illustrates the concept. A single device functions only because of a web of distinct, emerging tech ecosystems. Within this model, the processor node dictates the computational limits of the entire system. Because high-end research in AI, biotech, and space now relies on massive computational simulations, the nation controlling the underlying processor technology sets the physical speed limit for its rivals' progress. Innovation across these 5 sectors depends on the interplay between 2 foundational inputs: economic resources and human capital. This scatterplot maps the 25 nations in the index based on their available funding and the size of their specialized workforce. The United States maintains its position through a decentralized innovation ecosystem, where resources and authority are distributed across federal agencies, universities, and private corporations. China utilizes its scale differently, employing centralized, state-led planning to pool talent and capital towards specific industrial goals. Individual European nations often lag behind, but when their combined human capital and resources are aggregated, they form a formidable third pole that rivals China. While capital and talent are requirements, they cannot guarantee security if a nation lacks the physical infrastructure to build the hardware. Semiconductors hold a 35% weighted importance in the index because they are the physical bottleneck of the global economy. The life cycle of a chip is divided into 5 highly specialized segments. The United States dominates chip design and tools, authoring the architecture required to fit billions of transistors on a single chip. China controls the specialized materials node, leading the world in the mining and refining of the essential raw chemicals required for the physical wafers. The United States, Japan, and the Netherlands maintain a monopoly on the equipment needed to carve those designs onto the wafers. Taiwan and South Korea monopolize advanced fabrication, the actual manufacturing process. Finally, China leads in assembly and testing, packaging the chips before they reach device manufacturers. If the U.S. loses access to Taiwanese fabrication, or if Taiwan is cut off from Dutch equipment, the system halts. In this environment, total independence is a myth. Nations attempt to weaponize these choke points. Currently, the U.S. leverages its design and equipment monopolies through strict export controls to slow Chinese AI development. Because the supply chain is globally integrated, choking an adversary simultaneously inflicts asymmetric damage on domestic industries. This data from the report contrasts the financial fate of chip designer NVIDIA against toolmaker Applied Materials following the 2022 controls. NVIDIA's revenue rose because the global demand for AI data center chips completely offset the sales it lost in the Chinese market. Applied Materials grew by only 7%. Equipment manufacturers rely on frequent hardware orders from Chinese fabrication plants, making them highly exposed to these trade restrictions. Weaponizing a legacy choke point is a double-edged sword. To gain an advantage without self-harm, nations must identify entirely new technological frontiers. Quantum technology is that frontier. Unlike semiconductors, quantum ecosystems are currently in an early research phase. Because legacy infrastructure is not yet entrenched, quantum offers middle-tier nations a way to bypass the bottlenecks of established industries. However, the cost of entry is high. The United States and China have each invested over $9 billion in quantum research. No other individual nation has surpassed $3 billion. Middle-tier nations cannot match the US or China dollar for dollar in hardware. They must find an alternate route to gain relevance. The UK utilized its £2.5 billion state commitment to secure direct access to existing US infrastructure. This strategy led to a partnership between King's College London and Google Quantum AI. The agreement provides KCL researchers with access to the Willow quantum chip. This hardware can solve a theoretical problem in 5 minutes that would take a classical supercomputer 10 septillion years to complete. This hardware access allows KCL researchers to test models of natural systems like photosynthesis at the atomic level, research that is otherwise computationally impossible on standard UK infrastructure. By leasing hardware rather than building it, the UK bypassed the multi-billion-dollar manufacturing choke point. This quantum research feeds back into technological convergence. Algorithms developed on the Willow chip can accelerate drug discovery in the biotechnology sector. These advancements create path-dependent effects. The first alliance to solve these problems will set the global standards that everyone else must adopt. The Balfour Index shows that no single nation, regardless of its wealth, can secure the future alone. Geopolitical power now requires identifying critical national vulnerabilities and firmly integrating with allied ecosystems to cover those gaps. In this environment, total independence leads to obsolescence. Strategic, integrated leverage is the only true measure of power.